All right, cool. So we're going to get started here in just a second. All right. So hello and welcome to Reducing the Attack Surface. This is the first part in a multi-series webinar where we will be working from our brand new AWS account and reviewing attack surface reduction techniques within AWS. My name is Christopher Kaus, Managing Director of Cloud Security over here at Tevora, as well as your host for this webinar. Since today is all about the basics, let's review some key cloud concepts. Over the last couple of years in helping out our clients secure their cloud environments, I've noticed a couple of underlying themes that I paid attention to could dramatically reduce their attack surface. Today, I'm going to cover some of the most commonly used AWS services that, if misconfigured, could allow inadvertent access and expose sensitive information. We will be working from CIS hardening standards, since I have found them to be the most prescriptive. Additionally, since it's an industry standard hardening methodology, it'll help you meet various compliance requirements. Now to the terms. First one is Identity and Access Management, otherwise IAM. The next one is the Elastic Compute Cloud, or your EC2s. These are your virtual machines. The next one is the Simple Storage Service, or S3. This is where you store things. The next one is Virtual Private Cloud, or your VPC. This is what defines your networks and subnets. You also have VPC ACLs, or your network access control lists, and these act as a stateless firewall. It associates subnets and controls both inbound and outbound traffic at a subnet level. And the last one we have is EC2 security groups. These act as a stateful firewall for associated EC2 instances. Just a side note, although today we're focusing on AWS, a lot of these same principles do apply to Azure and Google Cloud. They may just have slightly different names. The first service we're covering today is Identity and Access Management, or IAM. Identity and Access Management takes a key role in any information security program. It ensures that only authorized and authenticated users can access your resources, and only in a manner that you intended. During the design phase, it is vital to define your principles. Those are your users, your groups, services, and roles that take action within your account. Then build out policies aligned with these principles to help implement strong credential management. These privilege management elements form a core of authentication and authorization. Now let's take a look at some ways to lock IAM down. When you access IAM for the first time, you will see that AWS recommends several identity best practices, along with convenient links to complete these security objectives. The first thing AWS prompts you to do is to delete access keys associated with the root account. This will prevent any programmatic access request made via root. Thankfully, this is something AWS has done automatically for us. To prevent human access, use a strong password to protect the root account, along with enabling multi-factor. There are various ways you can store these passwords. One way to control access is via a standalone secret manager, where it is required to enforce dual control when an organization needs to access the account, and an audit log is created to track any access. Next step, we are going to create an individual IAM user. Let's call him Dave C. Dave is a part of the SysOps group and requires management console access. We're going to select auto-generate password and require him to create a password on his next login. Next, we're going to add him to the administrator group. Now we're going to add a tag which relates to his job title. We will cover more about tags in future webinars. Now it's time to review the user settings. Success. Now all you need to do is share the account detail with Dave. Next, we're going to create an account requiring programmatic access called WebServe. We select the programmatic access box and apply the group API read only. We take a look at the permissions around API read only to make sure that it matches the group function. And we just take a look at the set permissions boundary option here as well. Again, we add a tag to the service account. And I decided to put another item in front of the tag so we could properly identify it later. We get a warning about the user not having any permissions, which we will address in a little bit. Again, the account is created. Next, I wanted to talk about policies and show you some of the default ones that are tied into AWS. Let's take a look at administrator access. You could see the permission ***, and we're going to take a brief look at the policy usage and policy versions. What I really want to point out here is the Access Advisor. Access Advisor shows service permissions that are granted to the user. This is a great way to validate if the appropriate access is granted. Now we're going to go back to groups and validate that the API read-only group does not have any users. Now we're going to add that web serve user that we initially created to that group. Again, we head back to Access Advisor to ensure the appropriate permissions have been applied. Excellent. Our last stop in our identity journey is to take a look at the account settings. Here we could specify password policies. I'm just going to harden these up a little bit here. There we go, all set. Now we go back to the dashboard to confirm that all the checkboxes are now green. Now that we covered IAM, let's chat about S3. It's what you guys have all heard about. It's all the rage in the news and something that is extremely easy to lock down. Today we're going to go through the steps of creating a public and private bucket and go over some of the security features available within S3. Next up, we're going to create a public and private buckets. The first bucket is going to be our private logs bucket, where we're going to send all of our audit activity. First thing we're going to do is create a private logs bucket. You have to have a unique name for the region, otherwise it's going to error out if you just wanted to call it logs bucket or logs bucket private. And then the next step, we're going to enable audit logging and have it logged to itself because there's no other buckets or an audit bucket actually assigned. Next, we're going to apply a few tags, similar to how we did over in IAM earlier. And take a look at a couple of the options here. You have the ability to do API activity, which is a good feature to enable. Right now, we don't have CloudTrail enabled, so it's not going to allow us to assign it to anything. And then the CloudWatch request metrics, which allow you to monitor requests to your bucket. We're going to skip on the default encryption for right now. For auditing, it's probably something that you actually want to have enabled, but we will cover that as well as the AWS KMS and future webinars. As you can see here, as we review the public access settings for the bucket, by default, AWS tries really hard to not make something public. The only thing that we're going to adjust here is manage the system permissions, and we are going to grant S3 log delivery group to actually write to this bucket, so we can have it audit more than just S3, but our environments, our systems, and so forth. We're going to review the settings that we created and create the bucket. Notice the access shows bucket and objects are not public. Now we're going to create the public bucket. And we're going to choose to log requests for the bucket to our private bucket. Again, we're going to use tags, which we'll cover in future webinars. And enable the CloudWatch request metrics. And instead of taking the public access the default public access settings that AWS provides, we're going to turn them all off. And we're going to go through what actually it takes to make a bucket public. So by default, you can see objects can be public for our public bucket, and bucket and objects are not public for our private bucket, giving us a little validation of the permissions that are around it. So within the public bucket here, we're just going to create a test folder. We're going to take a look at some of the actions here that we're able to do. And we're going to select Make Public. But still notice that we still get objects can be public. Now we're going to go through and we're going to modify some of the policies. Just showing you guys some of the stuff under Properties. And within Permissions, we're going to select Access Control List. And under Public Access, we're going to select everybody, and we're going to give everybody the ability to list objects and read the bucket permissions. What this allows you to do is if you go to like s3.aws.com/the bucket name, you'll be able to start actually listing out the folders and files within this directory. And the big thing is you have that big orange logo that shows things are public. In future webinars, we'll go over monitoring and alerting and how we can catch these things when they're actually created by accident in a production environment. So now let's transition over to networking. Careful management of network topology and design forms the foundation of how you provide isolation and boundaries for resources within your environment. It is critical to establish an appropriate network design for the workload that ensures that only desired network paths and routing are allowed. During this process, documentation of the network topology and consideration of components that are necessary along with the technology stacks involved are vital. In this exercise, we're going to create a VPC with public and private subnets. Next, let's get into some networking. Before we start, we need to create an elastic IP allocation. I'm going to select the one done by the Amazon pool. Next, we're going to launch the VPC wizard. Then we're going to select a VPC with a public and private subnet. I'm okay with the CIDR block. Give it a VPC name here. Let's call it Test VPC, something original. And let's establish our public and private CIDR range here. And next, we're going to select the elastic IP allocation ID that we just created. You can also use a NAT instance if you would like. We're not going to establish any endpoints, and we're going to ensure DNS host names is enabled. And then we let it do its thing. Excellent. Now the VPC has been created, let's dive in and see what actually occurred. We select your VPCs and select the test VPC that we just created. We're going to expand the bottom window here, take a look at the description, see what network ACLs and route tables are associated with. And let's dive into the actual public and private subnets and see how that was done. First, the public subnet. We're going to take a brief look at the description below. Let's take a look at the route table on the public subnet. You can see that the route table is tied to the local VPC CIDR block, as well as the internet gateway. This is one of the things we're going to check to make sure that the private subnet does not actually have. Next, we're going to take a look at the network ACLs. As you can see, there's just one rule, Rule 100, which has a source of quad zeros and an allow for all traffic. Just to recap a couple of things, the VPC's ACLs act as a stateless firewall, and it associates subnets, which control both inbound and outbound traffic at the subnet level, where the EC2 security groups, like we talked about earlier, are actually stateful firewall associated for the EC2 instances. Now let's take a look at the private subnet. Take a look at the route table, and as we expected, we see the NAT instance, but we do not see the internet gateway attached, which is great. Next, we'll take a look at the network ACLs again, and we'll see the same rule 100 with the quad zeros with an allow. In the next section, we will be tightening up the rule sets using EC2 security groups. Next, let's get into some networking. Before we start, Now that we went through the default network ACLs for a private and public subnet, let's recap on the differences between a stateful and stateless firewall. I know I've recapped on this a couple of times, just want to kind of point out the importance of each one. And now that we've kind of seen a live example, go over what each does. So to recap, your VPC ACLs, these are your stateless firewall. That's what we just created in the previous video with the public and private subnets. It acts as a stateless firewall by associating subnets and controlling inbound and outbound traffic at a subnet level. A stateless firewall essentially uses simple rule sets that do not account for the possibility that a packet might be received by a firewall pretending to be something that you asked for, versus an EC2 security group, which we're going to be covering next. These act as a stateful firewall for associated EC2 instances. Essentially, they can watch traffic streams from end to end. They are aware of communication paths and can tell what state a TCP connection is in. Various security frameworks, as well as many compliance standards, require that traffic is managed through a stateful firewall. The reason I bring this up is I have seen countless scenarios where an organization will attempt to enforce firewall rules through their VPC ACLs, finding quad zeros for inbound and outbound EC2 security groups. So now that we covered that at a high level, let's just jump in and create a security group. Let's dive into creating some security groups. The first security group we're going to create is the private group communication for our private subnet. Just putting in a brief description and then associating it with our VPC. Now we're going to create a custom inbound rule allowing SSH. For this example, we're going to use quad zeros, but it should be associated with where your organization wants its management traffic to actually come from. Next rule we're going to create is allowing HTTPS access from the reverse proxy to the web server. And then we're going to add a custom TCP rule allowing for database communication to the database server from the web server. Next, we're going to modify our outbound rule set, allowing for HTTPS communication from our private zone to our public zone. It's important to define egress restrictions. These are one of those things that I commonly see as quad zeros in organizations. Next, we're going to create a security group for our public subnet and associate it to the appropriate VPC. And what we're going to do is we're going to allow HTTPS communication inbound from quad zeros. As you can see, I used quad zeros and I also used IPv4 and IPv6. In our VPC, we just used IPv4. I just wanted to show you guys what it actually looks like. And we're going to remove the IPv6 addressing. Lastly, we're going to ensure that the default security group for the VPC restricts all traffic. When you create a VPC, it comes with a default security group whose initial settings are to deny all inbound traffic and allow all outbound traffic, and allow all traffic in between instances assigned to the security group. If you don't specify a security group when you launch an instance, the instance is automatically assigned to the default security group. Configuring the VPC's default security groups to restrict all traffic will encourage least privileged security group development and mindful placement of AWS resources into security groups, which will in turn reduce the exposure of these resources. So to wrap up, again, today is part one in a multi-series webinar. We started with a fresh AWS instance, covered some high-level security features of critical AWS services, and hardened them against an industry-standard hardening methodology, CIS. Now that we have a foundation on some areas that have the largest attack surface reduction, our upcoming webinars will be focused on exploring various ways to monitor the AWS environments and systems, followed by automation, where we'll be working with code to deploy uniform AWS accounts and systems to ensure security and compliance. This webinar will be available on our website or a SlideShare. Alex will send out the details on this. Within it, there's some helpful resources for you guys to kind of dig into the various topics that we talked about today. A little bit more about me, and then let's go over to a Q&A for the folks that we actually have in the room. I believe there is a questions, or you have the ability to raise hands, and then we'll kind of take it from there. All right. So the first question that I got is, hey, why did we not adjust the VPC ACLs? We'll dive into more of those on that in future webinars that we have, but essentially they're defining the network topology of the environment. They're defining your public and private subnets, and they also act as a stateless firewall. We have more because of various compliance requirements and security standards, and just because you want to use a stateful firewall to enforce those traffic restrictions, wanted to focus more heavily on EC2 security groups, especially since a lot of the organizations that I've been working with initially, the first step that they'll do is, tie down the VPC ACLs, but then there's no attention that's paid to EC2 security groups, which, may fail compliance and those type of things. I got another question here. Is there a difference in the setup in Lambda and EC2? There is, and Lambda is going to be one of those features that I'm going to be covering heavily in our automation webinar that we'll have right after the monitoring one, but definitely. And Lambda is a great feature that I could go on quite a bit about, but feel free to hit me up, email me. We could chat about it or stay tuned for the future webinar. The next question that I got was why quad zeros for the inbound security groups? It just really depends where you're accepting or where you're terminating TLS traffic from. Quad zeros, since in the setup we were using a reverse proxy, essentially for that. Or if you're using a WAF, you could have it assigned to that IP address as well. All right, perfect. I got another question on MFA. So this user's saying that every time they go to check IAM, they're seeing a bunch of users without enabling FFA, that they have that enforced through a policy, but it looks like it's just not being done. What's the best way to enforce it? So if you have like a corporate policy, it says you have to have MFA enabled, and you're seeing users not actually using the MFA, there's monitoring and alerting options that you can have to kind of, alerts on any type of compliance violations that you may have in that area. The other thing that you can do is issue hard tokens. When you're going through the user setup process, you could use like a YubiKey or something like that to actually require that token for when people log in. And then you could share that key along with the credentials for the user to initially access their account with. So I got another question about, there are a lot of standards and requirements out there for how to configure for the cloud. But if you went with default AWS configuration, what set of standard requirements would they align with? It really comes down to not necessarily the default AWS configuration, but the service that you're actually using. For example, when you set up the VPC networking itself, you have a public and private subnet, but communications internally are not restricted. So that's not meeting any type of like CIS framework or anything like that. But on the other hand, if you're using the default EC2, for IAM, the Debian instance that they have, that's hardened to CIS standards. It's still nice to run through the book because even though it's hardened to CIS standards, there's still some stuff with like SSH and PAMD that needs to get hardened. But yeah, usually it seems like AWS goes with CIS for hardening. Got another question about, aside from the CIS standards, is there any other framework or guidance that we can utilize to harden our cloud instances? It really depends what standard that exists. CIS is usually the most prescriptive, and they call out the actual controls that need to be applied. I found, with AWS, a lot of the stuff that they deploy for their managed services, they usually try to go to CIS. You have NIST frameworks that you could use as well. It's just in my experience, a lot of those frameworks, they're great, but they're a little overwhelming for some of the clients to initially implement, where they find CIS, especially as like a first step, to be a really good baseline because it'll tell you why they recommend having the control in place, how to actually audit to make sure that control is in place, what are the repercussions if the control is not in place, and how to actually enable it. Perfect. I'll leave the questions open for a little bit. See if anything else comes through. Got another question about any automated tools that we've seen that are helpful with compliance. Yeah, there's a couple tools that are helpful. We're going to kind of dive into a little bit of them on the monitoring side. I'm going to show the capabilities of the actual, like, hey, if like cloud trails are coming in, that type of stuff. Those could help out the compliance. There's other stuff out there like I think like cloud conformity or something like that, where they really have a really nice like tuned set of, hey, it's really easy to set up, and by the way, you're violating either SOC 2, PCI, HIPAA, high trust. Everything's kind of automatically built in. That's probably the easiest way to get up and running to monitor for compliance that I've enjoyed using. The other way that I've seen organizations build it out is using like AWS Lambda. A lot of the compliance stuff will be kind of set up as like a script with Lambda. So any type of like compliance violations that they're going to get automatically alerted on through there. And then also with Lambda, you could take, automatic remediation defined by however you want to respond to a certain incident. Perfect, guys. Well, I really appreciated you guys took the time out of today for this. Looking forward to doing a couple more webinars on cloud security. Again, feel free to reach out. Alex will be sending the slides out to everybody. You have my contact information. But any questions, feel free to reach out, and looking forward to having more conversations with all of you. Thank you.